Do you know what is Sp2 hybridization? If you don't know, you are at the right place because I will tell you what is Sp2 hybridization of carbon. Okay, so let's start with S and P. S and P are the orbitals of carbon of second shell, 2s and 2p. P is further divided into px, py and pz. If we write the electronic configuration of carbon, 1s2, 2s2, 2px1, 2py1. Okay, now in 2pz 0. So during the excited state, and this electron, one electron from these two jump to the 2pz and move here with the same spin. Okay, so you can write it 2s1, 2px1, 2py1, 2pz1. So this is the excited state. When it undergoes hybridization, after excitation, this is the ground state. Okay, this is the excited state. And what happened when the hybridization takes place? When the hybridization takes place, when an atom start to make bond, then hybridization takes place between these orbitals. What happened in hybridization? I have told you before in the video of Sp3 hybridization that mixing of these orbitals happens. How mixing happened? These four orbitals with different energy, but here, because this is Sp2 hybridization, the three orbitals with different energy mix to form Sp3 orbitals. Okay, 1 2 3. So 3 new orbitals are formed with one electron in them, and the 2pz is left behind unhybridized because this is Sp2 hybridization. Okay, so 1s and 2p orbitals hybridize to form 3 new orbitals which have equal energy, and the 2pz is left behind with different energy. It does not involve in overlapping. So actually what happened, this is s, this is px, this is py, this is pz. When the hybridization between them takes place, these become prominent. What become prominent? This sp2. This pose is sp2, this orbital is sp2, and this orbital is sp2 with one electron. And what happened to this pz? This remains here as sp2. This does not, this as s2 pz. This does not look like others. Okay, it is thinner than other and a longer one, so you can tell that this is 2pz. Okay, now this, when this is the hybridized state. Okay, now this will form bond with another carbon, so another carbon must be sp2 hybridized to make bond with this, or it make bond with hydrogen, then a single hydrogen s will form bond with it by overlapping. Okay, so what happened here when it make bond with other carbon and hydrogen, because it is the phenomena happened in alkene. Okay, so we have to make this bond. This is our last product. How can we make it? We make some shape like this. Okay, this is sp2, 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 and this is what? pz. Yes, you know it. All have one electron. Then what happened? It will overlap. This is another carbon, this is a carbon, this is a carbon. It also have one electron. Both have the same spin, but when they overlap, they will get opposite spin. Okay, this is 2pz. Okay, now this. Okay, when they both get overlap, they will become like this. Now you have to make these two orbitals here, these two orbitals here, and then 2pz, and then 2pz. You have to do all this step by step, as you can see how I am doing, just like that. Don't make like a toffee shape here, okay? Do it on purpose. What are you making? You should know what are you making, okay? Which orbital you are making, so when you will get this perfect picture. Now this is a bond, okay? sp2 sp2, I'm overlapping. Then what happened with them? 4 hydrogen atoms having 1s. When you combine with them, what will happen? The same shape you will make first, okay, like here, and then a bond, then a bond. You can make a double bond here. There was a single bond here, and now you add hydrogen and make it double bond, okay? Then you make another hydrogen. This is hydrogen, this is hydrogen, this is also hydrogen, this is also hydrogen. So 4 hydrogens attached, okay? Now there is 1 electron here, 1 electron here. What is this? It's 2pz, 2pz. Now these two will attract each other and try to overlap. They cannot overlap because it's big. They cannot overlap. It's side by side overlapping. They overlap like this, okay? What happened to this? They overlap on each other, but this is a sideways overlapping, so they cannot make a perfect bond here, but the bond exists. So we can write here a double bond. This is this bond sigma, and the sideways overlapping bond formed. This bond is known as pi bond. This is another carbon which form hydrogen bond, okay? Form with hydrogen. This is and this. Okay, so this is our alkene molecule. This is alkene or ethene. So sp2 hybridization takes place in those atoms which have to undergo double bonds, okay?